5.4, using triangle congruence and CPCTC. So first thing here, triangle ABC is congruent to triangle DEF by the blank congruence theorem. So let's look. Here I have a side congruent to that side, this side's congruent to that side, and then an angle here and an angle here. There I can see it is side, angle, side, side, angle, side. So side, angle, side. After proving they are congruent, you could also state that, so every other part is also congruent. So I can say that angle B is congruent to angle E. Those are corresponding angles. And then angle C is congruent to angle F. Those are corresponding angles. And then the two corresponding sides are also congruent. So BC, segment BC is congruent to segment EF. And that's true using CPCTC, which stands for corresponding parts of congruent triangles are congruent. So for example, if I know that two triangles are congruent, then JO would be congruent to RU. Looking at this first proof, we are given that angle 1 is congruent to angle 3. So again, in your picture, go ahead and label that to be true. And then angle 4 is congruent to angle 2. So I'm going to label that with 2 arcs. Angle 4 congruent to angle 2. We have to prove the RL is congruent to CD. So let's follow along here. So angle 4 is congruent to angle 2. That's given to us. And angle 1 is congruent to angle 3. That is also given to us. And then our next line says DL is congruent to LD. So DL is congruent to LD. We are talking about this segment both times. That is through the reflexive property. So I'm going to go ahead and label that to be true. Then I go right into saying that triangle DRL is congruent to triangle LCD. Here, that would be, let's look. So we have an angle here that's congruent to this angle here congruent to that angle, and then side on the inside. So we can say it's ASA congruence. So once I prove that two triangles are congruent, then any other corresponding part is also congruent. So I can say that RL is congruent to CD because those are two corresponding sides. So I can say that that is true through CPCTC. Corresponding parts of congruent triangles are congruent. And then in this proof, we just take it one step further and say that RL is equal to CD. That is the definition of congruent segments. So if I know that two segments are congruent, then their lengths have to be equal. And that is what is happening here. So I have two congruent segments, so I'm taking it one step further and saying, okay, if I know that there are two congruent segments, then their lengths have to be equal. So down here, we are given that segment YX is congruent to segment WX. So YX, right here, that was bad. So YX is congruent to WX. That is given to us. And we also given that segment ZX bisects angle YXW. So bisects, if a segment bisects an angle, it cuts the angle exactly in half. So that was also given to us. So then this next line says that angle YZX, so YZX, this angle is congruent to WXZ, this angle right here. That is true because of my angle bisector. It is the definition of angle bisector. We are using the fact that ZX bisects that whole angle and saying, okay, then the two smaller angles are congruent to each other. Next one here, classic, they're sharing a side. So they're sharing side XZ. So then I'm going to say that segment XZ is congruent to itself through the reflexive property. Once I have that done, mark it in my picture, and I can see that this is a side here and a side here, and then side here, angle, angle. So I can see it's side, angle, side, side, angle, side. So this is going to be side, angle, side congruence. And then this is what I was talking about, that 5.4 just adds that one little tiny thing on the end. And once I prove my two triangles congruent, then I can prove that the corresponding parts are congruent. And then that means that YZ is congruent to WZ through CPCTC. And that's all.